All right, we are back for day 2 of lesson 7.14. Today we're going to do the second part of it and do a little bit more calculations with it. I know the other day was more about conceptual thought, but now we're going to have to start using an actual figure, an actual prism, and then find the surface area of that. All right, so remember the other day we're trying to find surface area, which is the face of all the different sides of the prism. We have the bottom and the top, right? Or it could be this way, and then we have to add up all the sides up, and that'll give us surface area. So today we're going to use this figure over here, just right over here, and we're going to use the two strategies that we learned yesterday. Remember, the first one was adding all the areas of the faces, and the second one was making a big rectangle or a net, right? We're going to use a net to also find that area, surface area, right? Okay, so let's go ahead and look at the figure right over there. And actually, over here, I took some time and made an actual figure. This is a scaled copy of that. I basically used inches and divided it in half for each of those dimensions, right? So remember, if we're trying to find the area of the base, we're trying to find this front area right here, right? This front part right over there. Okay, so if I was trying to find that front part, I'm going to take that. I'm going to make a copy of it. Let me see if this works. But remember, that's the same thing as the back area. This is the back, and this is the front. All right. So let's try to find the area of that base. I'm going to move that over here. And let's see. Let's use green still. But this is 7. And it looks like this has to be 5 centimeters. This top higher is 3. That little part's 2. I don't quite know what that corner is. We could say that's 5, but that's not going to help us, all right? So remember, if we're trying to find the area of the base, we got to decompose it into different shapes. In this case, I have here 2 rectangles and a triangle, all right? So I know that for this first rectangle, that's going to be base times height, or I mean length times width, which is 3 times 5. That's 15. The bottom right, well, I need to find this portion here. I know that by doing 7, the whole part, minus 3 of that top, right? So this bottom minus the top gives me 4 of this remaining part. So that's a 4 by 2. So I know that this has to be 4 times 2, which gives me 8. And then if this is 4, we need to figure out the height of that triangle, right? The height of the triangle is going to be 5. So now we're taking the 5 minus the 2, and that gives us the 3, right? So over here, we have 1/2 times 4 times 3, right? And that should give us 1/2, so 4 is 2. 2 times 3 is 6. So those are answers now, right? We have here the base area, 15, 8, and 6. So if it's 15 plus 8 plus 6, that gives us, let's use our calculator, 23 plus 6, I think it's 29, but let's just double check. That gives us 29. So I know the area of this base, the area of this green part, this face part, is going to be equal to 29 centimeters cubed, or squared. 29 centimeters squared. All right. And again, that's by taking that face, moving it, cutting it up into rectangles and triangles, and then finding the area of each piece, and then we add them together. So remember, if this is our front part right here, right, this is our front part, we also know in the back is going to be the same as well. All right, so keep that in mind. So now let's kind of use this part where we're going to add all the areas of the faces to get surface area. So I know that this front part, so let me use blue to represent that. This front is going to be 29. And I know that back side is going to be 29, right? Because they're both the same. So I already know those ones. Well, now if I look at these other parts, I have the bottom part, right? I have the bottom part here. Well, that's going to be a 8 by 7. Do you see that? An 8 by 7 or 7 by 8. So that has to be 7 times 8, which is 56. I can see that here we have 2 and we have 8 right there. So this part right here, right, this part being this This side part, right, is a 8 by 2. So that's going to be an 8 times 2, which gives me 16. We have the slope, this turning, this side that's kind of going diagonally down, right? Well, that's going to be 5 by 8. So this one right here is a 5 by 8 because this right here is 8. And this is 5. So this is 8 times 5, which gives us 40. We're missing that top side, right? We're looking at the top side of this, looking at the top right now. Okay, you look at this, we look at this top side. That's a 3 by 8 or 8 by 3. So that's 8 times 3, which is 24. Last but not least, we have the side face, or this part right here, right? And that looks like it's going to be 8 by 5. So this is going to be 8 times 5, which gives us 40. Now I want to add all those numbers together. I'm going to highlight them in yellow. Those are the ones I want to add together. Okay, so let's add those up. So we got, in this case, our surface area. Well, that is equal to 29 plus 24 plus 40 plus 16 plus 56 plus 29 plus 40. Right, you got two 40s, it looks like. Okay, add those all up. We get 29 plus 24 plus 40 plus 16 plus 56 plus 29 plus 40. That gives me a total of, so the surface area now is going to be 234 centimeters squared. So that is our answer, okay? That is our surface area. So that took a lot of time. That took way too much time for me. But there's actually an easier way of doing this. Remember what we learned about nets the other day? So again, if I have my figure here, right? Well, what if I take this figure? Let's go ahead and look at this, the corner part over here. What if I take it all out? So I'm going to take that out as I'm going here. Try not to rip it. And I lay it flat out. What do you see? So you should see, right? You should see a rectangle, right? So what's going on is if I take that figure, right, that looked like this, and I flatten it all out, I get a rectangle. So what's going on is I have this face, which is, I'll move it here, make it a little smaller. I have that face and the back face, right? Well, we said both of those were, what, 29? Yeah, we said that both of those were 29. Yep, 29 centimeters squared. So these are 29 centimeters squared. And remember, surface area is when you add all of the faces together. So this is the front and back. And then we could add that big old rectangle that we just said, right? We took our shape. Let me see if I can get this correctly, right? We took our shape and then we flattened it all out. And that basically is going to be the height of 8. So this is 8. Let me use red to distinguish it. So it's going to be the length of 8. And then our width is going to be 7 plus 2 plus 5, 3, and 5, which I believe, using my calculator again, so 5 plus 7 plus 3 plus 5 plus 2 is 22. So this is a 22 by 8. So I know it's 22 times 8, which gives me 22 times 8, which gives me 176 centimeters squared, right? So now I can add all these up together. And what does that answer give me? You could pause and do it yourself. If I do 176 plus 29 plus 29, that gives me 234 centimeters squared. Okay, is that the same thing as the last one? You betcha, right? The reason is because we could take the pieces of all this, right? We could take the faces of everything, add it all up. That's going to be surface area. Whoops. Let me do this better. We could take this and all the faces, right? We can add them all up. Or we can make a big old rectangle of a net. We can make a net just like a volleyball, tennis net, and all the other nets, right? And we could just do base length times width. Okay, that's pretty much our lesson. So if we were to review these questions, first one says, how many different shapes did you need to calculate the area of when using the first method with all the faces? Well, I mean, that was a lot of them, but we could see we used 1, 2, 3, 4, 5, 6, 7 faces. That took us 7 faces to make that surface area. If we use the second method, that only took us 3, right? We had the rectangle and the base area of the 2 back and front faces. So which problem do you prefer? I don't know about you, but I prefer this way. This way was so much easier where you just kind of slayed it all out. You got the front and you got the back, and then just add them all up. This one took a little bit longer, but that one's okay too, right? Okay. So do you think you will prefer the same method for every problem? Depends, right? What would make you change methods? Well, it depends if you can't make a net. If I can't make a net, then I have to use the faces, right? But maybe the idea is first see if you can do a net. So I would say first find a net, and then second, if not, then just use faces. Use faces, right? That's the 2 methods you can do. All right, let's wrap it up. So what is surface area? You learned this last year, but it's the total area of all exposed faces of an object. What are some methods for calculating surface area of prisms? You could find the face of every single one, right? So you can find the face of every single one here. You can find the face, or you can just make a big triangle or a net, or a big rectangle, make a net, and then add those all up. All right? So that's what we learned today. We learned about taking the net and then finding the surface area of a prism. So go ahead and do that learning activity if you haven't yet. Other than that, just write down below what you learned, and that is for the lesson today. Okay? Have a great day. We'll see you next time.